right. Thank you so much. Thanks for coming. My name is Radek. I'm the technical director at Nozbe. And in this presentation, I will show you how we've built a truly cross-platform app, sharing the vast majority of our code between not just iOS and Android, but the web as well, without using React Native Web, ReactXP, or other existing solutions. The following is the distillation of what we've learned building Nozbe before. Our company has had a successful product on the market for 12 years, but throughout all of its iterations, it has always been a web app. And 3 years ago, we've decided to rewrite everything from scratch using React and React Native. Still, being a small company, it was extremely important for us to share as much code between all of the platforms as possible. So I'll show you a very small snippet of the app, just so you have the context as to what sort of challenges we faced and overcome in our quest to sharing code. So Nozbe is essentially a to-do app for teams, right? And this is filled with just randomly generated data. And notice a bunch of mobile-specific patterns here, like the drawer layout we have here. Now we have a project, and when I want to add a task, notice above the soft keyboard you have a bar with attributes I can add to a task. In the task, we have a discussion. You can see all the comments. You can tap on reactions, see who's reacted, add a new reaction. And if you want to add a new comment, we'll have a full-screen interface for that. And for both that and all of the menus and pickers, we'll have this bottom sheet card interface, which just makes a lot of sense on iOS. It's really nice to use, with some tweaks on Android as well. Now, contrast that with the desktop version, which is also the web version. As you can see, this is mostly the same thing, mostly looks kind of the same, works the same way. Layout is completely different, though. It's now not much bigger. It's all in columns. We don't have a soft keyboard, so the attributes are going to be on the right of the input. It doesn't make sense to use a card interface, so we use menus and popovers. Also, a lot of small tweaks, like everything is slightly smaller on desktop. We can use certain things like hover gestures, which are just not available on mobile. And certain patterns are just different for the web, such as if you want to add a new comment, it doesn't make sense to cover up the entire screen. It's better to have the discussion in context. Right? So as you can see, mostly the same thing, mostly the same UI, logic, product, but a lot of differences, small and big. So how do we fare with code reuse? How much code were we able to reuse between all of the platforms? As of last week, 82%. And of course, this is not just like business logic, data model, utilities. It's pretty much all of the components as well. So how do you do that? Well, one option is to go with one of these libraries. And this is sort of an easy way to go. Like, if you're starting out, you want something that's been tested, that a lot of other people done, this is the way to go. If you have a React Native app that's already built out, and now you need to port it to the web, use React Native Web. There's just not much else to pick from. But at least for us, when we started 2 years ago, none of the solutions that existed fit our bill. We didn't think that it's the right approach to take all of the React Native API and just bring it to the web, pretend that the web is React Native. We wanted to chart a different path for ourselves because we wanted to have flexibility, control over the abstractions, and really good performance. So instead of bringing React Native to the web, we wanted to have as lightweight as possible an abstraction layer that bridges React Native and the web instead of bringing React Native to the web. So we don't use any of that. So how do we do that instead? So let's start by talking just project structure. How do you go about having a shared code base? We have everything in one monorepo. There's one repository for the entire app, and it comes in 3 chunks. One is the app folder, and it contains all of the application code, all of the application JavaScript. The native folder is for React Native specific things, so React Native configuration, the Xcode project, the Android project, all of the native Swift and Kotlin code we've written, and the web folder is mostly for Webpack configuration and things like that. We also have multiple package JSONs. The root one is purely for development tools such as Babel, ESLint, Jest. App package JSON is purely for application dependencies that are shared across the board. Native package JSON is for React Native specific tooling, as well as app dependencies that only work for React Native, just to keep things organized. And the same for the web. And just like in React Native, you can have .ios.js and Android.js files. We also configured all of our tools to accept web.js and native.js when we have to differentiate between those two platforms. So there's a lot of tools that you need to make aware of this setup, that they understand the monorepo and understand the custom file extensions. So unfortunately, I won't go into the nuts and bolts of how to configure that, because this could take the entire talk. But what we plan on doing is either to write it up as a blog post or open source a full project template later this year. OK, so we have the monorepo. Then we need kind of an infrastructure layer, the base building blocks upon which we can build our app. The most important of which is, of course, React and React Native. We have that. But there's another piece that was really important for us. So hands up, just out of curiosity, how many of you know WatermelonDB? All right, some people, cool. So here's the thing. We needed some sort of data persistence layer for the app. And the thing about Nozbe, it's an offline first app. So you have all of your stuff downloaded offline on the device. And it's not uncommon to have tens of thousands of records in the app, all the projects, tasks, and comments. So we need really good performance. It needs to be scalable. The very common approach of just going with persisting a Redux or a MobX store just doesn't work. Trying to load all of that at up launch would slow things down tremendously. So we need a real database. We need everything to be lazily loaded. But because the app is really interactive, we also need it to be observable, reactive. We need to be able to easily connect the data source to components so that they re-render when the data changed, which is kind of hard to combine with lazy loading. It needs to be capable of server synchronization because it's an offline first app, and then you synchronize with the server to get the same thing across all devices. And of course, it needs to be multi-platform. It needs to understand iOS, Android, and the web. So nothing like that existed. And last year, we open sourced WatermelonDB. And you can check it out online if that's relevant for your project. All right, let's talk about styling. This is the first major obstacle to sharing components between React Native and the web. And you already know this, but just the API is completely different. Here we have divs and spans on the web. We have capital V views and texts. Here we have class names. Here we have style. It's just the API difference is untenable. We can't use it like that. We need an abstraction layer. So we really like the approach of styled components, not necessarily the styled dash component library, but a lot of libraries like that, because this abstracts away HTML and CSS. But at least when we started, no such library existed that would be both cross-platform between React Native and the web and be high performance. So we created one. And here's how it works. When you want to make a box or text, you import view or text from style. That abstracts away the difference between view and div, span, and text. And then you import styles from a local file for the component. And you just define the styled component. If you used something like styled components, this is broadly recognizable. A box is a view. Its main style is style.box. If you want conditional styles, you add that in. If you want to pass explicit styles, you add that in. And then in the render method or the function component, you just use it like a normal component, right? This way, we neither directly use the DOM, nor do we import React Native. And now the styles. So, OK, here we do need two different files, unfortunately, because of the approach we took. So we have styles.native.js, which just exports as a style sheet, and a styles web CSS with the CSS classes. And we use post CSS in the Webpack configuration such that the CSS file is importable from JavaScript. So just import styles and it will import the right thing, depending on whether you compile for React Native or the web. Still, even though we're duplicating that part, which is unfortunate, we do want to share as much as possible. So what we do is we have a single style constants file. So we try not to ever use literals in the styles file, like colors, sizes, margins, paddings, text styles. Instead, we have a standardized palette of all the colors and sizes in one file, and then you either import that in native, or you use this CSS variables syntax, which post-CSS compiles to the literal. And this way, this is a good practice in general, but particularly when we do need those two separate parts, it's easier to just keep things shared and in control. So we were thinking of open sourcing our styled components library since it's working pretty well for us. But we think we have an even better idea. See, the problem is that our application is big and complex enough that the performance overhead of having like actual components for each and every box and piece of text is no longer negligible. So we have a project in the works, which is codenamed ZAX for Zero Abstraction Cost Styling, that would still allow us to have a completely shared abstraction for building styled components, but the entire abstraction would be implemented at compile level as a bubble plugin, such that the runtime cost of this is 0. If all goes well, which we'll see, we'll open source that later this year. OK, let's talk about shared components. The first step is to build a small library of very base UI components. And I just mean the sort of components whose implementation is completely platform dependent. So this is an almost complete list. There's not as many of those as you might think. But something like image, text input, icon for vector icons, or touchable, which on the web might be an anchor or a button or a div on press. You just have to make 2 different implementations. But there's just a couple of them. It's not a big deal. And now that we have those few layers of abstraction, the base UI components library and a styling approach, making actual styled components, shared components is trivial. Like, there's not that much to show. You just build styled components, and you compose them together with the base UI components library. And this way, you neither have to import React Native or refer to DOM-specific things in the component index.js file. That's it in most cases. Of course, the devil is in the details. And since we did not take the approach of bringing React Native to the web, you'll still have to deal with many platform differences, and you'll have to resolve them. So the first and simplest approach is to just if-else it. And just like React Native has a platform export that allows you to differentiate between iOS and Android, we have the same thing, but we also add isWeb and isNative to the mix. In most cases, that's really all that's needed. Most differences are very simple. The second approach is to abstract the differences using helpers. So, for example, when you have a text input, the events of those work slightly differently on the web and in React Native. On the web, you might have something like event target value. On React Native, events native, event text. It's not a big deal. You could if-else it. But it just becomes tiring when you have to do it in 10 different places. So there's a lot of just really small trivial differences like that. And what we do is you just make a simple helper, like this is essentially one line of code, with index.web.js, index.native.js. You encapsulate the entire difference between those 2 platforms. And then in actual components, you don't see that difference. You just import a helper, use that, and all of the component level code is the same. The third approach is what we call platform files. So imagine you have, say you have the root component of your app, right? It probably has a lot of things that are completely shared between all of the places. You probably have some context providers, maybe some shared logic, but some things are obviously different. On the web, you might have a simple column-based layout, just like we do. And on React Native, you might be using some sort of drawer layout, React navigation, what have you. So you don't want to duplicate all of the code since there are shared parts, but also you need to resolve those differences. So a common technique that we use is we just have an index.js file with everything that's shared, and the differences are extracted into a platform web.js file and platform native.js file. And then you just put all of the snippets of components that are different or little helper functions that are just specific for this one component. And this approach is particularly useful when you have to import dependencies that only work on one of those two platforms. Because if you put it in an index.js file, a lot of libraries, a lot of tools like Babel, Webpack will just get really confused by this. So in JS files, you only import things that are available everywhere. In that WebJS, that native.js, you import things that are different. And then you can re-export it so that the index.js file might use it. And for the other platform, you just export a placeholder, such as a no-op function or a component that doesn't actually render anything. OK, but sometimes that's not enough. As a last-ditch effort, if you can't really share it, you might have to do two different implementations. When will it be necessary? One case is when you have big platform differences. And again, this is something like image, text input. There's not a lot of those. The second reason to have two different implementations is when you want to have a completely different design. For example, you saw in my screencast how we have these menus and pickers that have the same content on all the platforms, but are represented visually differently, such as a popover on the web and a bottom sheet card on native. So we have just one component for it. We call it model. But it has two different implementations that implement a completely different design. The third reason to have this is when you abstract over different dependencies. For instance, we have a component called list, because pretty much all of our lists are drag and droppable. And on native, you need something like flat list for list virtualization to get good performance. So we don't want all of the components, all of the pages to have to think about it and know about those differences. So instead, we have components like list with two different implementations that wrap over two different external libraries and provide a common API for the rest of the app. It's important to note that even when you do need two different implementations, you don't want to duplicate yourself if it's not absolutely necessary. So when you do have parts that are shared, extract them, like extract common logic to a hook or a header component and put it in a common JS file that then you import from the two different implementations. Or if you have a really big, complicated component, you should probably split it into smaller parts. And some of these might be completely shared. And really, that's all that's needed for 80–85% code reuse. Still, there are some missing pieces. We think we can do even better and maybe get to 90% or more without compromises, with just this approach of having a shared lightweight abstraction that shares across React Native and the web, not bringing React Native to the web. For example, styling. So my 82% figure, OK, I lied a little bit, doesn't include the styling, the styles that are a little bit duplicated. So React Native Web has the solution of just compiling style sheet to CSS, but we really didn't want to do that. And I don't think this is a lost cause. I think we can build a tool that will provide an API that's as shared as possible, but just statically compiles the styles for CSS and then for React Native. I think we can do this performantly without compromises. Animations work in a completely different way, just completely different sets of tools. There are many React animations libraries, but last time we did the research on it, most of them were frankly not very good because they drove the animations from JavaScript, and they just won't get you very nice, smooth animations. So actually, we do have a partial solution. It's only for static animations. It won't work when you need something like React Native gesture handler for interactive animations. But for static animations, we made a very small, simple library that essentially implements the React Native animated API, but it's built on top of Web Animations API. So it actually has really nice, smooth 60 FPS animations. Would anyone want to see that open sourced? Yeah. Nice. OK, well, think about it. Bundling. Two different bundlers. That's slightly annoying because those are like pretty big, complex pieces of infrastructure that we just have to maintain. And we think the future is with Whole, which is CallStack's project to bring Webpack to React Native. Last time we checked, it still had some missing pieces, but if not today, then very soon, I hope we can completely share that. And then there's just a lot of small and big UI components that you're just not going to implement yourself, such as list virtualization, drag and drop, navigation, and what you see is what you get editors for like comments or something. And in all of these cases, we had to use two different implementations, two different third-party libraries, and then make a lightweight abstraction to bridge them together. For WYSIWYG, WordPress recently made a Gutenberg editor, which might be a solution to this. And for other items on that list, there's some work in that direction, like with React Navigation. But for now, we can't truly share that. And then last but not least, end-to-end testing. Lower levels of testing you can pretty easily share, but for end-to-end testing, we have two great but completely different libraries, Cypress and Detox. It would be great to build an open source, a common abstraction to bridge the two together, or maybe start with a completely different approach, like use KV and build that out to be like truly fully featured. That would be great. All right. Now, before I leave the stage, I want to share something with you. A controversial opinion. I think it's controversial. So in the beginning, when you wanted to have an app, you built the app. And if you wanted to have an app for iOS and for Android, you build an iOS app and an Android app. But what about if you want a web app, an iOS app, an Android app, a macOS app, and a Windows app? That would be great, right? For an app like ours, that would be perfect. But then with the correct approach of writing it everywhere, now you have to hire and build out 5 different teams that will design the same app, implement the same app, fix those same issues over and over again. This is wasteful and really disheartening when you build something that somebody already built just against a slightly different framework. And it's really expensive. I mean, think about it. Even big companies like Twitter or Slack can't make native macOS apps. It's just too much. So someone came up with a great idea. Let's just write it once and run it everywhere, right? It's the 2000s. Let's just write everything in Java. And 10 years later, let's just write everything in JavaScript. Put it in a Electron or PhoneGap. Run it everywhere. That's great, right? No. The problem here is it almost inevitably leads to bad user experience. Each platform is unique and different, and users have different expectations. That needs to be respected. And so React Native came up with this great mantra: learn once, write everywhere. Now this is great. I love this. The idea here is you only have to learn the React paradigm once, right, and JavaScript. And then you can use this knowledge to target the web and React Native. It appreciates the need to not redo work where only there are technical differences, but at the same time, there are platform differences as well. They need to be respected. But is that enough? I don't think that's enough. Yes, that's great that we learn once, write everywhere. But why do we have to write everywhere? Yes, there are UX differences that need to be respected, but a lot of differences between React Native and the web are merely technical differences. They're just incidental complexity, not real one. So I want to propose a new mantra for the community. The galactic brain choice. Write once, learn everywhere. Let me explain. Here's the idea. If 90% of your app, of its logic, UI, layout is the same, so should be the code. You shouldn't go for 100% code reuse. You should go for 90% code reuse. Each platform needs to be respected, right? But we shouldn't have to write the same thing over and over again just because of some technical differences. Like, isn't that just silly? So I think we should write once everything that is the same. But we shouldn't just be lazy and like, oh, we've written it once and now we run it everywhere. No, we don't run it everywhere. Now that we've saved time by writing it once, we can reinvest that time to learn all of the platforms. And I think if we really want to step up our game and make a really great user experience, we should learn all of the platforms. Yes, we want to share as much code as possible, but you should learn DOM and CSS and HTML and UIKit, Swift, Kotlin, to make a truly great user experience, right? So you write once everything that is the same, and then you reinvest that to make a truly great app for all of the platforms. All right, thank you.